Hi students, let's look at this question which was taken from the year 2018 ACJC Media Exam question 3. This question is on integration, and the first part is to ask you to use substitution to actually find the integral of the root x over 1 minus x dx and find it. I think should be quite okay. Basically, the second question is to find the volume. So even if you can't do the first one, you could actually use the second. You could use the first part result to actually find the second one. That is the first thing that I would recommend you to do if you can't do the first part. Without further ado, let's just try and see how we can solve this proficiently. Okay, so the first thing for any kind of substitution, just to find the derivative of the substitute first. Okay, so just dx d theta. I think from dx d theta you will get 2 sine theta, and then differentiate cosine. Differentiate sine will just be this, right? So this is it. In other words, your this part here, which is square root x 1 minus x dx, this is actually x equals to sine square, right? So let's see how we could solve this. So you could actually replace your dx as your 2 sine theta cos theta d theta. So just write this out as 2 sine theta cos theta d theta as such. Okay, so anyway, this part here, what we're going to get is actually just square root. X is actually just, I'm just going to replace everything in. I think this question should be quite okay. And we'll try and see what I can get out of this. So this part here, once we get it ready, we would actually just separate the top and the bottom. So this is quite typical. 1 minus sine square theta. So the first thing is that you should be able to tell that this is actually your cosine square theta. Okay, because now if you want to get rid of it, root, right, that would like probably be helpful, because if you square root it and you could simplify it, it would be much better. So anyway, this is sine theta on top, and this is square root cosine square theta, the one below. All right, so that's about it. Once we're done with that, this will be 2 sine theta cosine square theta d theta. So you realize that this could cancel with this. This would be, after you open the root, it could be cancelled, right? This would be simplified to a very simple form, which is sine square theta. Okay, now sine square theta, once you see sine square theta, what you need to know is actually you need to use the double angle formula for cosine 2 theta. So cosine 2 theta 2a, cosine 2a is actually 1 minus 2 sine square a. Alright, so just use this formula here, because this could be integrated and this could be integrated. So what you can't integrate is sine square theta. So in this case here, if you were to use this formula, what we'll get is actually eventually this would be 1 minus cos 2 theta over 2 d theta. Alright, and then basically what you get is 1 minus cosine theta d theta d theta. This is pretty cool. Then basically this is theta minus sine 2 theta half plus c. That's about it. But obviously you're asked to change back to x, so I think it's really not a big issue. If you want to change back to x, you should just look at this expression here, which is actually x sine square theta. X equals to sine square theta. So this part here, sine square theta will be plus root x or minus root x. Okay, so then the question is, should you take the negative or the positive x? Because this is in Q1, right? Q1 would just means that sine theta is positive. Reject since sine theta is positive. So this is important. So you get sine theta as root x. So this part here is in the quadrant 1. So you could safely draw a Q1 expression here. So this is root x over 1, opposite. So this is 1 minus x square. 1 minus x square root. So this is 1 minus square root. So this is root just by Pythagoras lah. So there you go. So once you get all this ready, it's pretty okay. This theta. So since sine theta is equals to root x, hence a theta is actually sine inverse root x lah. So this is sine inverse root x. And this because we are sine 2 theta is 2 cosine theta sine theta is we do not have the double angle formula, but from this triangle we just need a single angle here, right? So what we're going to do is actually just sine inverse root x equals cosine would just be root 1 minus x over 1, sine x would just be root x over 1, which is what we get, right? Yeah, that's it. So this part here is okay. Sine inverse root x minus x 1 minus x plus c. Okay, that's how you do this question here, proficient. I think this first part is pretty okay. We've practiced properly. Proper practice should be quite fast for the first one. Okay, shouldn't be too difficult. So what you should do is just understand the step-by-step process. It's a pretty common combination of techniques. Okay, so let's look at part 2. Part 2, you're asked that the region bounded by this expression here, and then the y-axis and y equals to 1 is denoted by r. Find the exact volume of revolution of r through the x-axis. Okay, great. So what we're going to do is, if you're not sure what's going on, I would suggest you just use your GC and sketch it out. And we're going to see how this going to pan out. All right. So that's it. Load up with GC and basically plot it. Clear. So this is the fourth root. So I think we could just leave it as such. X 1 minus x. All right. And then what else we have? To the power of 1 over 4. So this is fourth root. And yeah, so that's it. So just zoom standard first and try and get, okay, this is the graph here. So I could see that actually what I want is from x-axis y. So I'm just going to adjust my window. There are quite a lot of redundant stuff going around here. So I'm just going to put minus, let's say 0.5, and probably x max I'll just put like 2.5, I guess. 2.5, and let's say I would just put it 3, and y mean minus 0.5, and let's say this I put as 3 as well. So just adjust to the place where I'm looking. Yeah, look, try and get a nice curve here. It will be helpful. Not sure whether it will pass by origin, doesn't matter. Just press trace and press 0. You have to be sure of what you're doing. So this case here, you know that this graph goes up here and it ends. So y equals to 1 would be here, right? This is y equals to 1. Am I right? So you are looking at the graph. Yeah. So just roughly have the graph by your side to be able to gauge what's going on. Okay. So that is one of the techniques. So what I'm going to do is actually just going to put the graph in and see how it goes. Okay. I think the main thing is to know what is the area that you're looking at. So sometimes students just rush into things. I would suggest you just, take your time. This is 3 marks. So if you want the exact volume, so yeah, 3 marks would be just nice. So this graph here, you want this graph here. Okay, so this is actually the graph, and then the y-axis, which is this one here, and the line y equals to 1, so it's about here lah. Okay, so this is y equals to 1. Yeah, so it doesn't take much long for you to know that it's this area here. This is R. Okay, and revolve about the x-axis. Oh, cool. So you are revolving about this x-axis here. So revolve about here. So I hope you could visualize how this thing looks like. So it's like a okay, let me use a SketchUp to show you how it looks like. Okay, some students may have a problem understanding how this looks like. So I will just sketch it out for you, and you can have a look at how it looks like, so that it helps you to visualize it. Okay. This part here, once you essentially want to rotate about the x-axis. So Some students have problem understanding that this graph here actually is like a cylinder minus off um, the area under graph. I will understand that because yeah, you need some form of like spatial intelligence to tell that actually this is the thing that you're looking at, right? See, so can you see that it's actually a cylinder minus of the area under this graph here? So what the volume that you get is actually the one below here lah. So I hope you can visualize this. Yeah. So it's not. Okay, we try. I'll probably just show you how this looks like. Okay. Yeah, that's how you look at. So what you need is actually the required volume. First of all, we need to find the x value lah, because we do not know what is the x value there. What you could do is just sub 1 inside. I'm not sure 1 x equals to 1. Yeah, so this is x equals to 1 I believe. So because when y equals to 1, y equals to 1, is it 1? Then you have 1 equals to 4x over 1 minus x. I hope it's 1. So what's x? Oh no, it's not. So it's 2x equals to 1. My bad. Oh yeah, it's half. Okay, so this is half. So this value here is half. Okay, so the required volume would just be, if you could visualize, just like I told you, right? The volume that you will get is the you take the cylinder, which is this one here, this one. So the cylinder minus of the protruding like that. This area, the volume under the graph. Okay, so it looks like this lah. So the SketchUp that we saw just now, right? You're looking at this is this over here minus of the I hope, yeah, like that. Yes, so this is what you need to minus off. Basically this cylinder is okay. If you are comfortable in finding the cylinder length, then you just go ahead. So this is I will just find the radius of the cylinder, and then this is the length, which is half. So the this will be one unit, and this over here will be half. So this will be actually pi r square h minus of the integral of 0 to half y square pi dx, right? So we need to find y square. Y square would just means that yeah, you just square it lah. So this will be like pi, half pi. Did they want exact? Oh yeah, they want exact. So this will be 0 half power of 4, which is x over 1 minus x, right? 1/4 square it. So it's just the actually the integral that we found just now. Okay, I know some students do struggle with visualizing the volume. I would suggest you know, just practice it, and if you can't visualize it, just let me know. I could actually model things out quite fast for you to be able to see. Yeah, it requires some spatial intelligence, because it could be difficult, but yeah, just press on. Okay, practice it. It will work lah. So this is sine inverse x and minus x. We get this as 12, 0. Okay, half and 0. So this would be actually half pi minus pi. This is sine inverse 1 over root 2. It's just a special angle. This would be half times half, which is 1/4. 1/4, and 0 minus 0 lah. So this would be sine inverse root 2 will be actually just half pi minus pi. That will be pi over 6 minus half. Okay, so this would be actually half a pi. So half a pi, this is pi minus 1 over 6 pi square. I hope that's the answer. Oh man. Oh yeah, it is pi over 4. Oh yeah, 1 over 2 is pi over 4. I'm sorry. Pi over 4. Sine over 4. 1 over 2. Should have used my calculator. So this is, sorry, this is pi over 4. So this is pi square over 4. Yeah, that's your answer there. Alright, so any question or comments, let me know. Text me, get hold of me, and I'll try and explain this question for you. Alright, it's pretty typical question, I would say. Yeah. Okay, so keep practicing. I'll see you in the next video.